The volume of a rectangular box with a square bottom and open top is V equals x squared y, and its surface area is A equals x squared plus 4xy, where x represents its width and length, and y represents its height. Estimate graphically the dimensions of a box with V equals 1,183 cubic inches and A equals 702 square inches. Is your answer unique? Hint: substitute appropriate values for V and A and then solve each equation for y. So our volume equation, V equals x squared y, we're told that the volume is 1,183, so we would have 1,183 equals x squared y. Solving this equation for y means dividing both sides by x squared. So in terms of entering it into the calculator, it would be y sub 1 is equal to 1,183, and then we use the division slash x squared. For the area, the equation is x squared plus 4xy, and the area is 702, so we substitute that. 702 equals x squared plus 4xy. Subtract x squared from each side, and we have 702 minus x squared equals 4xy. Next, we would have to divide both sides by the 4x so that we isolate y. So in the calculator, we would enter it as y sub 2, and that's going to equal, in parentheses, the expression 702 minus x squared slash, in parentheses, 4x. And it's very important that we put this in parentheses, because if we were just to put slash 4x, it would look at it as divide by 4, multiply by x. So now let's go enter these into the calculator and find where those two graphs intersect. To enter these equations into the graphing calculator, we use the equation editor, or the y equals key. So y sub 1 is 1,183 divided by x squared. So we write press the x variable key followed by the x squared key. Use the down arrow key to move to y sub 2. And this time we're going to enter an expression, so we use a parenthesis with the open parenthesis key, 702 minus, now we press the x variable key followed by the x squared key so that we get 702 minus x squared. We close the parentheses, and now we want to divide that, so press the division key, and now open the parenthesis because what we want to divide by is 4 and x. So press the x variable key, now close the parenthesis. In addition to this, you'll find that we need to adjust the window, the viewing window, in order for our graphs to show us the intersection. By a little trial and error, I found that we should use -5 as the minimum x value, +25 as the maximum x value. We'll use a scale of 5. For the minimum y value, we are going to use -5. For the maximum y value, 25, and for the scale, 5. Now let's graph these by pressing the graph key, and we'll see the first graph come in. And now the second graph is very similar, but you will see a little bit of space showing that there are 2 points of intersection. To find both points of intersection, we use second calc number 5 for intersect, and it's asking, is the first curve y sub 1? And the answer is yes, so press enter. It's asking if the second curve is y sub 2. The answer is yes, so press enter. And now it wants us to guess the answer, primarily because it wants to know, do we want the one that's to the left or the one to the right? Let's start with the one to the left, so let me move the cursor a little bit closer to that point of intersection. and then simply press, and I do that by moving it to the left with the left arrow key. Now press enter, and it comes up with the fact that the intersection occurs at x equals 7.2933926 and y equals 22.239527. Now, let's go find the second point of intersection, the one that's over on the right. So press second, calc, and 5. It's asking, is the first curve y sub 1? Yes, so press enter. Now, is the second curve y sub 2? Yes, so press enter. Now we need to move the cursor to the right so it's closer to that point of intersection. So press the right arrow key, press and hold it down, and you'll see it'll move automatically. It's getting close, and so let's say there. We press enter. So it shows us that the intersection occurs at x equals 22.084701 and y equals 2.4255023. So what we are interested in is, of course, both of those points of intersection, and we can approximate those values. So we would approximate the first one as x equals approximately 7.29 and y equals approximately 22.26. And for the second point, x is equal to 22.08 approximately, and y is approximately 2.43. And now let's write those on the board. So having found the points of intersection, let's write those solutions on the board. We have one set of solutions, which is x is approximately 7.29 and y is approximately equal to 22.24. The other solution, the other point of intersection, was x is approximately equal to 08, and the y value is approximately equal to 2.43. Now they ask us, is our solution unique? Well, you can see that we've come up with two possible solutions, so no, it is not a unique solution.